Hi, Year 13, it's Miss K here. I do hope that all of you are keeping well and safe. Today's lesson is an introduction into statistical testing, and I know that we've covered this briefly in our study of psychology, but it is important that we have a greater depth in terms of our understanding of how we choose statistical tests. What's the point of conducting a statistical test or statistical analysis in a study. To start off with, I would like you to copy out the statistical test decision tree, which is going to come up on the next slide. So you can pause the video when you see it. And then shortly to follow after, there will be a table. So that you might decide that actually a flowchart doesn't work for you. You're not able to remember it and a table works for you. That's fine. So for those next two slides, I would just encourage you to pause the video when it comes up and copy it out because you're going to need it for later on in this lesson. So you can pause the video here and start copying out this wonderful statistical test decision tree from Tutor2U. Once you've taken this down, later on in the lesson we'll go through how we actually operate this decision tree. On the next slide you will see a table, and you can also pause and copy that out if you prefer the table to the flowchart. And here's the table for those who prefer this format. You can pause the video here and take it down for your notes. Inferential statistics are used by psychologists and other researchers to determine the likelihood that an observed effect is due to chance. By observed effect, we mean a difference between two sets of scores or an association between variables or a correlation. The statistics allow the researchers to make inferences or conclusions, predictions about the populations from which the samples are drawn. And this is where we get our understanding of population validity, because we know that if a study is conducted on 10 people, then perhaps the inferences that we can make towards a broader population are very slim. You need to know which test is appropriate in different circumstances, so that's in different experimental circumstances. And one of the decisions that you need to make is whether or not the test is parametric or non-parametric. P is for powerful, and parametric tests are indeed powerful. They are the most powerful type of statistical test that you can use. And this is because they use the actual scores rather than ranked scores. And we're going to understand the differences between those later on. There are certain criteria that you need to meet in order to use a parametric test. The first thing is that the data must be interval. And remember, with interval data, it's likened to, there are different examples such as height, weight, and this is where the difference between 1 kg and 2 kg is always going to be 1 kg. It's never going to differ. So the intervals between each data point remains the same. It's not manipulated by the researcher where we would find that in ordinal data. The data needs to come from a normally distributed population. So that is where, if you were to plot your scores, it should fit a nice bell-shaped curve to indicate that it is normally distributed. And remember that our normally distributed graph, the mean, median, and mode tend to sit along the same area, the same line towards the center. And there's homogeneity of variance. Now, this is going to make sense when we say that if, for example, you are comparing two groups, you are saying that the spread of the data in each of those groups, they are similar to one another. So if I say the standard deviation in group 1 was 2.7 and the standard deviation in group 2 was 2.6, we would say that there's a homogeneity of variance. If, for example, group 1 had a standard deviation of 5, meaning that the data was much more spread, and group 2 had a standard deviation of 1.9, we would say there's a lack of homogeneity of variance, and therefore a parametric test may not be suitable. Having said all of that, the main criterion that needs to be met in order for us to choose a parametric test is that the data must be interval. So you might be able to use a parametric test without homogeneous data. You might also be able to use it without normally distributed data, but you certainly cannot use a parametric test without data that is interval. If the data is ordinal or if it's nominal, you cannot use a parametric test. So we've talked about parametric tests, and now it's time to look at non-parametric tests. And we remember that the main criterion for a parametric test is that the data should be interval. If the main criteria for a parametric test is not met, then a non-parametric test needs to be used instead. Non-parametric tests use ordinal or nominal data, and ordinal data is data that you can put in order. Nominal data is categorical data. Now, in psychology, you don't need to know how to carry out these statistical tests, but you do need to know the criteria for choosing each test and how to read the statistical tables. And this is just information that you need to know. It's not information that you need to like. You just need to know it, especially because research methods and long answer research methods questions will always include a question on statistical tests. So we've returned back to our statistical test decision tree or flowchart. And remember that we always start off by ensuring that whenever we enter an exam situation that has research methods included, especially for those of you going off to university, you may have a research methods paper. It's so important that the first thing that you do is offload this flowchart, meaning just quickly jot it down in the corner of your exam paper, and that way you can readily, refer to it for any question that requires you to produce knowledge on statistical testing. We always start off with the question, can you use a parametric test? And because this word parametric means powerful, we understand that in essence, we're asking ourselves, is the data interval? If the data is interval, we come to this side, and once we determine the type of data that is being used, we ask, is the data correlational? If the data is correlational, then of course we would say Pearson's R, which is a correlational statistical test. If the data isn't correlational, then we need to ask ourselves, okay, so it's not correlational, it's definitely a test of difference, and it's quite tiny there. It's a test of difference, but we know that a test of difference can be both independent groups design or repeated measures design. Independent groups, we are looking at an unrelated t-test, and if it's repeated measures, we are looking at a related t-test. If we go back up to the top, can you use a parametric test? I'm going to change my color. If it's no, first thing that you ask is the data nominal? And the way I like to remember it is no and then nominal, N-O. If the data is nominal, meaning that the data can be put into categories, then we come over to this side. Yes, we've determined our type of data. Remember that you cannot correlate categorical data, so you're not going to be asking, is it correlational? That's not done because you cannot correlate categorical data. You come to this side, you've determined the type of data, it's not a correlation, so you have to ask yourself, was an independent groups design used? If an independent groups design was used, then it's a chi-square test. And if not, if it was a repeated measures or a matched pairs, then it's the sign test. We then come back to whether the data is nominal. And this time we're saying, well, the data is not nominal, and we've also determined that the data was not interval. Therefore, of the three types of data, so you've got interval, nominal, and ordinal, ratio is one that we don't really consider. So just three types, interval, nominal, and ordinal. If it's not interval and it's not nominal, then it must be what? Ordinal. So we've determined the type of data, it's ordinal. You can correlate ordinal data. That's why you would ask yourself, is the data correlational? If it indeed is correlational, then you would use a Spearman's row test. And if the data is not correlational, then you would need to ask yourself, was an independent groups design used? If yes, then it's Mann-Whitney. And I use a very funny example to differentiate between the two. If no, then it's Wilcoxon. The way I like to remember it is that Mann-Whitney, independent of each other, two separate people, they're not married. Wilcoxon, however, repeated groups, they are married, they share the same surname. Whatever works for you to help you remember this, do what you need to do. The most important thing is that you know it and you're able to produce it on demand. So you may come across a question that asks you to justify what statistical test can be used for a particular scenario. And the first thing that you need to do is to find out what type of data was generated from that particular experiment or correlation. We've got three types of data. The first one we're going to look at is nominal data. Nominal data is data that can be put into specific categories. This information can be presented in bar charts, but certainly we cannot correlate categorical data. So tests such as Pearson's and Spearman's Rho are out of the question when it comes to nominal data. Ordinal data is data that is continuous. However, it's continuous in the sense that it is a researcher who determines the skill or determines the scores that are going to be attributed to participants. For example, you might be asked to go out and measure participants' happiness scores, and I give you the freedom to decide how you're going to do that. Some of you may say, I'm going to measure happiness on a scale of 0 to 25. Others might say, I'm going to measure them on a scale of 1 to 50. Another person might say, I'm going to measure them on a scale of 0 to 10. You can see that there is some inconsistencies in the type of scale that we use. And this is why this type of data is ordinal and not interval. Lastly, we have interval data, and remember that interval data is the most powerful type of data. It's the one that meets the criteria for a parametric test. Interval data is also continuous, but it represents things that are set in stone that the researcher cannot manipulate. For example, height, time, weight, length, and so on. And like I said earlier, this is because the intervals between each data point on an interval set of data is predetermined. It's not something that is manipulated by the researcher. The difference between 1 kg and 2 kg will always be 1 kg. I hope this makes sense. Once you have determined the type of data, you have to work out what type of experimental design has been used and whether it is a test of difference or correlation. There are a range of experimental designs that are used in psychology, and I'm going to quickly go through each of them and hopefully provide an example as I do discuss them. If a participant's before and after scores are used in the study or in the experiment, then it is a repeated measures design and it is a test of difference. For example, what I might do is I might get a group of students to sit an exam in the morning, and I'll get that same group to sit an exam in the afternoon. And if I'm comparing their scores, I'm looking for a difference between their scores depending on whether it was in the morning or in the afternoon. And it's repeated because I'm using the same set of participants. If the participants are only used once in that group's condition, and you use a different set of participants for another condition, that would be an independent groups design. So it might be if I get one of my year 13 classes to do the exam in the morning and one of my year 13 classes to do an exam in the afternoon, and I compare them that way, it's independent groups because I've used a different set of participants for each level of the independent variable. And also when it comes to matched pairs design, so we understand that matched pairs design is where you match participants based on certain qualities or characteristics that might be considered to be an extraneous variable. That is likened to a repeated measures design, and also it is a test of difference because you're still looking for a difference between the manipulation of your independent variable. Lastly, if it is a non-experimental research design, whereby the researcher measures two variables and assesses the statistical relationship or association between them, it is a correlational design and it is a test of relationship. So notice that we've highlighted the different experimental designs, but we've also highlighted whether or not it's a test of difference or whether it's a test of relationship. And that is absolutely crucial for when you are deciding a statistical test. So back to this handy flowchart again, and I just want us to engage in a particular activity, which is if I highlight a particular statistical test and I say to you, can you tell me when we would use Spearman's Rho? I would expect you to use your flowchart and say, well, we'll use Spearman's Rho when the data is correlational. We'll also use it if our data is ordinal, because the data is not interval and it's not nominal. If I was to also ask you here, when would we use an unrelated t-test? You would say to me, Miss, we use it if an independent groups design was used. We also use it if our data is parametric. And we also use it if it is a test of difference. And then a last example, can you tell me when we would use a chi-square test? You'd say to me, Miss, we use a chi-square test if it was an independent groups design. And we also use the chi-square test if our data is nominal. And indeed, it's a test of difference. If we were to quickly go through each of these statistical tests and just identify which one's a test of difference and which one's a correlation, Pearson's is a correlation, unrelated t-test, test of difference, related t-test, test of difference, chi-square, test of difference, sign test, test of difference, Spearman's row, correlational, Mann-Whitney, test of difference, Wilcoxon, test of difference. Okay, so let's practice some exam questions. Make sure that you've got your flowchart to hand because I can't put it up on the same screen due to it coming up very, very tiny if I do that. So the question says, a group of researchers is testing whether the number of words that can be recalled from a list is affected by age. One group of participants is under 30 years old and the other group of participants is over 50 years old. Participants have to learn and recall words from a list of 100. Each participant is given a recall score out of 100. Table 2 shows the data from the investigation. So you've got the mean score out of 100, you've got the two groups here as well. And we can see just at face value that the over 50s are doing slightly better than the under 30-year-olds. The question is, explain which statistical test the researchers could have used to analyze the data. And I've got some prompt questions here for you. What type of data was generated? Well, if we go to our key piece here, if we go back to the stem, it says they've had to learn and recall words from a list of 100 and given a recall score out of 100. We would say that this type of data is ordinal data. This is because any researcher could say, well, I'm going to give them a recall score out of 50 or out of 75, but they've chosen 100, so it's ordinal data. What is the experimental design? Well, they are comparing two different groups, and we would suggest that that is an independent groups design. This is because each group is experiencing a different level of the independent variable. And what statistical test is the right one? So based on our understanding that the data is ordinal and that it is an independent groups design, and it's also a test of difference, what statistical test would you go for? Well, I'll give you the answer now. It's a Mann-Whitney test. It's a test of difference, the data is ordinal, and it's an independent groups design like we have determined. Another exam question for us to consider. It says two psychology students are arguing as to whether males or females would be more likely to stop and help a woman with a baby in a pushchair up the stairs at a busy train station. They decide to settle the argument by carrying out a structured observation. State two reasons why chi-squared might be an appropriate statistical test for this study. Now for this you are going to need to look at your flowchart and work your way up from the point where you've got chi-square and look at the decisions that led you to chi-square in the first place. And I'm visualizing my flowchart. I don't have one in front of me, but to help you through that process, we think about chi-square. Chi-square is a test of difference. We use it when we are working with an independent groups design, and in this case you're comparing men and women, so therefore they are two separate groups, they are two categories. Also, you go a step further and the data is nominal. The data is nominal because you've got your categories. So our three reasons for choosing chi-square is that in this particular study, you're looking at comparing males and females. That's an independent groups design, but also it's categorical data. And thirdly, it's a test of difference. Notice that in this particular question, they've asked you why it would be an appropriate statistical test for this study. And it's really important that you learn to contextualize your answer. By contextualize your answer, I just mean refer back to the STEM, even in research methods questions. So at this stage, I want you to pause the video and I want you to check your knowledge of choosing the correct statistical test using this particular quiz that I found on Sporkle. I'm going to put the link in the description box below, and I'm also going to put the link on Show My Homework. Make sure that you screenshot your score and you send it to me via Show My Homework. I'm looking forward to seeing 100%. And for this quiz, you only have 3 minutes to answer the questions, and there's only 8 questions. It's very, very easy. Light work for you guys. So a researcher begins their work by writing a hypothesis. Remember that a hypothesis is a statement that predicts the outcome of a study. Your hypothesis can be directional or non-directional, and I know that you guys know the difference between those two things, so I'm not going to tell you now. A statistical test is used finally to determine whether the hypothesis is true and can be accepted, or whether the null hypothesis should be accepted. A hypothesis can never be strictly true. Rather, the calculation is based on probability. And this is why in psychology we have a significance level of 5%. And that 5% gives us a little bit of room for doubt, a little bit of room to say, well, it might be that our results from this experiment or from this correlation are due to chance. But it does mean that we can be 95% confident that any effect that we observe in our experiment or in our correlation is due to our own manipulation of the variables. There are some studies where their level of significance is much stricter, so they might leave just a 1% probability that the results are due to chance. And this is perhaps due to the fact that there's certain studies that if you leave the margin too wide, there could be a risk to life. So every single statistical test will produce a calculated value, and this calculated value is compared to the critical value, which is found in a table to check for significance and whether or not we can accept our hypothesis or the null hypothesis. Every single test that we look at, indeed, you don't need to calculate the calculated value, you don't need to work it out, it's always going to be given to you, but you do need to understand it in relation to the critical value. There are two types of tests within a statistical test table of critical values, and they are the one-tailed test or the two-tailed test. One-tailed tests are used for directional hypotheses, and two-tailed tests are used for non-directional hypotheses. And it's at this point which I will help those who perhaps are still confused as to the difference between a directional hypothesis and a non-directional one. Directional hypothesis literally states a direction that you expect your results to be from your experiment or your correlation. And a non-directional one doesn't state the direction, it just says that there will be a difference or there will be a correlation. It doesn't say that so-and-so group will perform much better than so-and-so group, and it doesn't say, oh, there will be a positive correlation or there will be a negative correlation. It leaves it very open. How do we know which critical value to use? Well, there are three main criteria points. We've got the first decision, which is understanding the nature of our hypothesis. So if our hypothesis is directional, then we need to be using a one-tailed test. If it's non-directional, it needs to be two-tailed. We need to know the number of participants, and in a chi-square test, which I'm going to come and teach you guys later on, that's slightly different because it's grouped. So you're looking at nominal data. But in general, we need to know the number of participants, which is known as N in capital letters. And you also need to know the level of significance. So a question will say you need to tell me whether or not this particular test is significant at the p less than 0.05 level. There might be a cheeky question that asks you at the p 0.01 level, but it's very important that you have a look at that just to be sure that you're getting the right critical value. So here's an example table of critical values, and I'm going to quickly talk through its features just to make sure that you are understanding how to read and understand a critical values table. This one is specifically for the Spearman's row test, which is a correlational test. We use Spearman's row if our data is ordinal and if we are looking for a test of relationship. So you can see here on this side, you've got your number of participants, and they've only given us 3 sets here, so 29, 30, and 31. And then this is where some students find it tricky, but you guys will not find it tricky. In Jesus' name, you're going to know it, you're going to understand it. So it says level of significance for a two-tailed test and level of significance for a one-tailed test. Now remember, in psychology, generally speaking, we use the 0.05 level, yeah? And if, let's say, for example, we had a STEM that preceded this particular table, and they said to us, yes, our hypothesis was a directional hypothesis. If it's directional, then you know that you are looking for all the values under the one-tailed test region. And that means this column right here is your column of interest for a one-tailed test in psychology if you're looking at the p less than 0.05 level. If, on the other hand, the STEM told you that indeed this particular experiment had a non-directional hypothesis, so they said there will be a difference, but they haven't stated the difference, or they said there will be a correlation, but they haven't stated the type of correlation, you'll be looking at the 0.05 level here, yes, and you will be looking at this column. Now, the thing that trips most students up, I should say, is they get confused about the headings. But don't get confused about the headings. Just follow, read, just basic English, read it, and follow where it says 0.05. I hope this makes sense. If you have any questions, make sure you email me. You must be able to decide whether or not the test is significant. And this is where we see the importance of the letter R. Tests with the letter R in their name are those where the calculated value, which is always given to you, must be equal to or greater than the critical value, which you have to find using your table of critical values. Tests without the letter R in their name are those where the calculated value must be less than the critical value. So let's just quickly go through. Spearman's rho has an R, so therefore the calculated value for Spearman's rho must be greater than or equal to the critical value in order for the test to be considered significant. Chi-square has an R in it, so it follows that same pattern. Mann-Whitney does not have an R. Therefore, in a Mann-Whitney statistical test, the calculated value has to be less than the critical value in order for the test to be deemed significant. And when we talk about deemed significant, we are simply saying that the difference that we found is not due to chance. It's very much due to the manipulation that occurred in our particular study. If our results are insignificant, we are saying that any differences that have occurred haven't occurred due to our manipulation. It's just occurred by chance. Okay, so let's practice deciding significance with this exam question. If you are working on using your phone, you might want to zoom in. If it's possible, take a screenshot, zoom in. So this question says, some studies have suggested that there may be a relationship between intelligence and happiness. To investigate this claim, a psychologist used a standardized test to measure intelligence in a sample of 30 children aged 11 years, who were chosen from a local secondary school. He also asked the children to complete a self-report questionnaire designed to measure happiness. The score from the intelligence test was correlated with the score from the happiness questionnaire. The psychologist used a Spearman's rho test to analyze the data. He found that the correlation between intelligence and happiness at age 11 was plus 0.42. So the plus there indicates that it's a positive correlation. The psychologist used a non-directional hypothesis. Using the table below, state whether or not the correlation between intelligence and happiness at age 11, and this is our calculated value, plus 0.42 was significant. Explain your answer. Now let's take our time with this. Let's work through it very, very slowly. The first thing that we need to identify is how many participants this researcher had. And we can see the number of participants here in the STEM. It says 30 children age 11. So therefore we know that the row that we are interested in is this row because of our number of participants. We also need to understand whether or not the test was two-tailed or one-tailed. So if we go back and let's look for where he states what type of hypothesis. It says the psychologist used a non-directional hypothesis. Sorry about my highlighting skills. So non-directional hypothesis. Non-directional is synonymous with a two-tailed test. So we know that we are interested in this particular column, or row rather. And then finally, we know that in psychology we use 0.05. They haven't really specified it in the STEM, but you use your knowledge. 0.05 is what we are interested in. This means that our column of interest is this column. Our row of interest is this one. Therefore, if we had to determine our critical value, this will be our critical value. So our critical value is 0.362. If we compare that to our calculated value, which is 0.42, and we know that Spearman, which is the name of the test, Spearman has an R in it, we are expecting, in order for our results to be significant, we are expecting our calculated value to be greater than or equal to the critical value. In this situation, our calculated value is greater than the critical value. Therefore, we would say that our results are significant at the p less than 0.05 level. I hope this makes sense to all of you. Well done for making it this far. I'm very, very proud of you, especially for the home learning that you are doing at the moment. Biggest well done. And these skills will certainly help you as you go off to university, or for those of you who are going into the world of work. Best believe you will come across scenarios where you might have to determine whether or not the difference between maybe two products is significant enough. So yeah, well done. So today we've covered choosing a statistical test, we've covered understanding significance, we've practiced exam questions, we've broadened our specialist vocabulary, especially with key terms such as homogeneity of variance. The next things that I would like you to do is to complete the apply your knowledge questions on page 25, and also complete the research methods exam questions attached via show my homework. I'm expecting that to be submitted using the submission box on show my homework. Remember that you need to send me your screenshot of the quiz as well that you completed. And of course, feel free to use this video as part of your revision, or share it with your friends who perhaps are studying psychology in different schools and are struggling. But well done and take care.